Some fiber reinforced filaments are very brittle, and they may break inside the printer. Now I want to check if actively heated chamber will reduce this brittleness of the filament. Hello, welcome to my tech farm. Recently I got two comments who mentioned that Qidi suggests heating up the chamber to 65 degrees Celsius for those brittle filaments, and with this we are reducing the chance that they will break inside the Teflon tube inside the printer. Now, since that I couldn't find this claim on the Qidi website, maybe it's in some forum or Facebook group, I'm not sure. But anyway, this comment was enough to woke up my curiosity. So I want to check if the heating of the filament to 65 degrees Celsius will make it less brittle compared to room temperature. Now I know that even without actively heated chamber, the temperature inside a closed printer may go up to 40-45 degrees Celsius at least, depending on the room temperature. But I want to compare these two temperatures, room temperature approximately 20-25 degrees Celsius versus 65 degrees Celsius, to see any difference in the brittleness. And for this actually I have a great tool. Only this one is from the PLA, I'm not sure if it will survive this bigger temperature. So the plan is very simple. I will place some filament segment into 65 degrees Celsius, not inside the printer, but I will use the filament dryer. It is also accurate. And I will try to measure its brittleness as fast as possible and compare it with the filament which was on the room temperature. And I will do this with the several very brittle filaments. Maybe you already know that the Polymaker is the channel sponsor. And from them I will include the two filaments in this video, but this experiment is only about filament itself, not about 3D printed objects. And I know that I will get a lot of comments. Don't worry, in very near future I will test the correlation between actively heated chamber and the layer adhesion with at least 5 different filaments, but as I mentioned, in a separate video. Now let's see the filaments from this test. Qidi PAHT-GF 50% shop glass fibers, Polymaker ABS-CF10, Polymaker PPS-CF10, Qidi PET-GF, PET reinforced with glass fibers, YXPolyer PC-CF, polycarbonate reinforced with the carbon fibers. And usually these filaments are so brittle that I cannot use the holes to lock into the filament, so or I have to stick it to the side or I have to use this kind of clips. Now I prepared those filament segments, and black filaments are marked ABS-CF with the white line, PC-CF with the gold, and PPS without any marking. It's always interesting to hear this metallic sound of the PPS. Segments are prepared and marked, only I'm thinking I will reprint this from the PETG, just in case, because in theory it will have a contact with almost 65 degrees Celsius filament. Just very short playing with numbers. If we start from the speed of 100 mm per second, from the flow we can calculate the speed of the filament, which is 3.3 mm per second. And let's say we have some longer printer and the tube inside the printer is 500 mm. In that case, the time which will the filament spend in that actively heated chamber is 2.5 minutes. And in my case I will wait 5 minutes. If there is any positive effect of heating, I want to be sure that I can measure it. And as I predicted, I couldn't resist to print this from the PETG. Now I feel much more comfortable when it will have a contact with almost 65 degrees Celsius filament. But first let's measure our reference on room temperature. All measurings will be recorded because I want to analyze the footage to be sure that the reading is correct. I'm not sure what will I show in the video because I know it may be boring if it is too long. Starting with ABS-CF, start angle 30 degrees. 65, something like that. PAHT-GF based on PPA, start angle 30 degrees. 75. PC-CF marked with this gold line, start angle 25 degrees. Around 75. PET-GF start angle 30 degrees. Almost 90. PPS start angle 25. Around 70. Start angle 27 degrees. And now let's start with the heating. Sanlo E2 filament dryer, but this is a prototype very inaccurate, so I have to control the temperature with my own thermometer. But I want to use this one because it has this nice tray and I can place the test objects there. Yes, interesting situation. When they sent this to me, they mentioned this is a prototype and asked me not to mention those errors which are in the prototype because they are fixed in mass production. Or at least highlight that that's only the prototype. And now I have to mention this in every single video. No other company stopped sending me the products for the review. This is what I was talking about. Set temperature is 65 degrees Celsius and I can measure 73-74 degrees inside. And only now when I reduce here the temperature, it stabilizes around 64-65 degrees Celsius and I can insert the first group. And after 5 minutes I will just take them out and I immediately start with the measuring. Only I will zoom the camera here on the tool. Now I want to be very quick. Start angle 30. I think there is no changes, but I will analyze the footage at the end. PET-GF, start angle 30 degrees. Maybe 75. PC-CF, start angle 27 degrees. 75. Start angle 25. PET-GF, start angle 32 degrees. The last measuring, PPS, 27 degree. Now let's analyze the results. Well, it's measured on room temperature and after exposed to 65 degrees Celsius. And in this table we can see the average values, but same is presented on this graph. Now we can see that in most cases, after the heating, the filament became more brittle. But if we watch this standard deviation, then we can tell that this difference is basically negligible. Now there is one small detail which still makes me think that the heating will make the filament more brittle. 2 times the filament broke on 2 places, which is the typical sign of the brittle filament. I think it is quite obvious that the heating will not reduce the brittleness of the filament, so I believe that this myth is busted. Maybe it even have the opposite effect, but the difference is completely negligible. Now there is one more myth I want to check, and that's the correlation between accurately heated chamber and the layer adhesion. So far I tested this only with one filament during the review, and the results are quite positive, but I want to test this with many other filament types, and I hope you will follow me to that video too. Until then, thank you for watching this video till the end, and happy printing!